right, you all just finished a U-Try where you got to add or subtract to simplify radical expressions, and I gave you two different ones, one that was a little simpler and one that was a little more complicated. So, first one I gave you was 3 square root of 5 plus 7 square root of 5. This one was already simplified, you're welcome. You just got to add them. They are like radicals, they both have square root of 5, so they are like terms. So all we do is add the coefficients. 3 plus 7 would be 10, and then we'll keep the radical part the same. It'll still be square root of 5, and that's your answer for the first one, is 10 square root of 5. For the second one, it was a little more interesting. You started out with 6q squared, cube root of 5q, minus 2q, cube root of 40q to the 4th. All right, well, the 5q can't be simplified at all because 5 is prime. It's not going to break into a group of 3. And there's just one q, so we also don't have a group of 3 q's to take out. So that's as simplified as the first one's going to be. But you can simplify the second one. So 40, you can break that down into 8 times 5. 5 is prime, but 8 can be broken down into 4 times 2. And 4 is 2 times 2. Oops. Started circling a little early there. It is a cube root, so you're looking for a group of 3. We have 3 2's, okay, that we can take out. With the q to the 4th, there are 1, 2, 3, 4 q's that are multiplied together. You're doing a cube root, so we're looking for a group of 3, so we can take 3 q's out. So when you do that, we're just going to multiply things together. So we're going to have this 2 times that 2, which would be 4. We'll have this q times that group of q's that we're bringing out, and q times q would be q squared. It's still a cube root. And the things that are inside the radical are the things that didn't get put into groups, so this 5 and that q would be put into the radical. They didn't have a group to go into. So there's the simplified version of the second radical. First one stayed the same, so we're just going to rewrite it. 6q squared, cube root of 5q, and there's subtraction between the two, okay? At this point, they are like radicals. They're both cube roots, and they're both cube roots of 5q. So we can subtract those. The coefficients are even like terms, so that's kind of exciting. We have a 6q squared minus 4q squared, which would be 2q squared. And then the radical part stays the same. It's still a cube root, and it's still a cube root of 5q. So that's your answer for the second one.